arithmetic progressions. What are arithmetic progressions? We'll just go and see here. This is chapter 5. The concepts we'll see first, then we'll go into the exercise problems. Now in this we'll be learning about what are terms, what is the sequence, what is the AP, what is nth term, what is sum of first n terms and all. So first we'll just consider some list of numbers, see some examples. From that we'll try to do what is a term and what is a sequence. So consider the following lists of numbers. Suppose you consider it as 2, 4, 6, 8, so on. There's the first list. Second one, 58, 56, 54, so on. Then suppose you're having one more list as 12, 7, 2, -3, -8, so on. Next, one more list as 3, 3, 3, 3, 3, and so on. Then one more you're having it as, we'll take this as fifth one. So you can write this as 4 by 3, 3 by 2, 5 by 3, and so on. Then one more we'll take 4, 9, 14, 19, and so on. Now each of the numbers in this list are nothing but they're called as called a term. Okay, whether they are a sequence, whether they follow a certain order or not, we'll just check it out. So now each number in the list is called a term. Okay, now this will become the first term, this will become the second, third, fourth term, and so on. So each and every element or every number in the list, whatever is given, each and every whatever I have taken the list is called as a term. So above set are arranged in a definite order. That is, all of them follow certain rules. So we'll just see what is it. Now sequence. What is a sequence? We'll see. Sequence is a set of numbers arranged in a definite order according to some rule. That list of numbers should follow some definite rule. So sequence is a set of numbers arranged in a definite order according to some rule. Now in each of these sequences which are written over here, because they follow some certain rule, what is the rule? We'll just see. In the first one we can see that each term is 2 more than the previous term, the preceding term. So if you are adding plus 2 to 2, you're getting 4. If you are adding plus 2 to 4, you're getting 6. If you are adding plus 2 to 6, you're getting 8. In the second sequence, what is happening? If you are minusing 2, 58 minus 2 is 56. 56 minus 2 is 54. So the next term will be 54 minus 2, which is 52. Now in the third one, what do you see? You can see what is the difference over here. It is 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 5 is minus 3. Minus 3 minus 5 is minus 8, and so on. So now here in the next one, what you are having here, each term is obtained by adding one constant term. What is that constant term we are adding here throughout? We are adding plus 0 for each and every term. So this is also following a certain sequence over here. Now in the next one, 4 by 3 plus 1 by 6. So you can see here 3 by 2 minus 4 by 3, you're getting it as 1 by 6. So each term in this is more 1 by 6 more than its preceding term. So if you are adding, you are going to get the next term. If you are adding 3 by 2 plus 1 by 6, you are going to get 5 by 3. You can just see here 4 by 3 plus 1 by 6. If you are taking the LCM as 6, so what are you going to get here? You are going to get it as 8 plus 1 by 6, which is 9 by 6. So 3 3s are 3 2s are, which is 3 by 2. Similarly, if you are adding 3 by 2 to 1 by 6, you are going to get it as 5 by 3. Now here in the last sixth one, what you are getting? 4 plus how much is 9? 9 plus how much is 14? And 14 plus how much is 19? So 4 plus 5 is 9. 9 plus 5 is 14. 14 plus 5 is 19. So such sequences are said to be, in all the sequences you can see that the successive term is obtained by adding a fixed. So in all the above sequences, we see that each successive term is obtained by adding a fixed number to the preceding term. So such sequences are said to form an arithmetic progression. Such sequences are said to form an arithmetic progression, which is called as AP. So what is AP? AP is a sequence in which each term except the first one differs from its preceding term by a fixed term. So the fixed number is called, now here you're having a fixed number is either added or subtracted to each and every term. So therefore, an AP is a AP is a sequence in which each term except the first one differs from its preceding term by a fixed number. This fixed number is called the common difference of the AP. This fixed number is called the common difference of the AP. We can denote the first term of an AP by A1, the second term. So first term is denoted as A1, second term as A2, third term as A3, and so on, AN. And the common difference is A2 minus A1, which is equal to A3 minus A2, which is equal to AN minus 1. So how do we find out to find the nth term of an AP? Let us consider an AP with first term A and common difference D, then the first term is equal to a1, which is equal to a plus d, which is equal to a plus 1 minus 1 into d. The second term is equal to a2, which is equal to a plus d, a plus 2 minus 1 into d. The third term is a3, which is equal to a plus 2d, which is equal to, this first term is a1 is equal to a plus 0d, which is equal to a plus 1 minus 1 into d. Second term is equal to a2, which is equal to a plus 1d, which is equal to a plus 2d. So a plus 3 minus 1 into d. The fourth term is equal to a4. A plus 3d is equal to a plus 4 minus 1 into d. The nth term, a plus n minus 1 into d. So the nth term, Tn of the AP with first term a and common difference d is given by an is equal to a plus n minus 1 into d. Now next we'll see how to find the nth term from the end of an AP. To find the nth term from the end of an AP. Let us consider an AP with first term a and difference t. To find the nth term from the end of an AP, let us consider an AP with first term a and common difference d. Let L be the last term of this AP. Now we can write the AP as follows. A plus D, a plus 2D, a plus 3D, so on, L minus 3D, L minus 2D, L minus D, comma L, where here L is nothing but the last. Here last term is equal to L. Now second term from the end is equal to L minus D, which is equal to L minus 2 minus 1 into D. third term from the end is equal to L minus 2D, which is equal to L minus 3 minus 1 into D. Fourth term from the end is equal to L minus 3D, which is equal to L minus 4 minus 1 into D. So therefore nth term from the end is equal to L minus n minus 1 into D. Next, to find the sum of n terms of an AP. To find the sum of first n terms of an AP. AP of n terms, consider an AP containing n terms. Let Sn be the sum of n terms of this AP. Then let Sn be the sum of n terms of this AP. Sn is equal to A plus D, A plus 2D. So we are adding all the terms, plus on, plus L minus 3D, plus L minus 2D, plus L minus D plus L. This is the first one. Now writing Sn in reverse order, we get Sn is equal to A plus L. In reverse order, we can write it as L plus L minus D plus L minus 2D plus L minus 3D plus so on, plus A plus 2D plus A plus D plus A. Take this as the second equation. Now adding 1 and 2, equation 1 and equation 2, we get 2Sn. We can see from there 2Sn is equal to A plus L plus A plus D plus L minus D plus A plus 2D plus L minus 2D plus so on, plus A plus L minus 3D plus 2D plus, sorry, this is 2D, plus, because last third term, that is, plus A plus L minus D plus D plus A plus L. So now you can cancel out these terms here. So therefore you are getting it as 2Sn is equal to A plus L plus A plus L plus A plus L plus so on, plus A plus L plus A plus L. So this is how many times we are writing A plus L. So 2Sn is equal to A plus L plus A plus L plus so on n times. So when we are writing it as n times, what does it mean? N into A plus L. So 2Sn is equal to a plus L, or Sn is equal to n by 2 into a plus L. Now since you know that last term L is equal to An, which is equal to a plus n minus 1 into d, so putting this value of L in this, putting the value of L in Sn, we get Sn is equal to n by 2 a plus n minus 1 into d, which is equal to n by 2 into 2a plus n minus 1 into d. So this is the sum of n terms of an AP. Exercise 5.1, chapter 5. So what is the first problem? We'll see. In which of the following situation does the list of numbers involved make an arithmetic progression in y? So first one, the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So for this solution, we have first taxi fare for 1 kilometer is equal to 15 rupees, that is A1. Taxi fare for 2 kilometers is equal to rupees 15 plus 8, which is equal to 23 rupees. This is A2. Then taxi fare for 3 kilometers is equal to 23 plus 8, which is equal to the third term, that is 31, is A3. So in the same way, if you take for 4 kilometers, it will become 31 plus 8. So therefore, and so on. So therefore, you are having A2 minus A1 is equal to, A2 is 23. 23 minus 15 is equal to 18. A3 minus A2 is equal to 31 minus 23, which is equal to 18. So that is, we have an minus 1 minus an is constant. So this list of numbers form an arithmetic progression. We have to see whether they are following a particular sequence or not. So since they are following a particular sequence and you are having a common difference of 8, you are adding 8 to them for getting the next term. So therefore, arithmetic progression with first term A equal to rupees 15 and common difference D is equal to rupees 8. Now what's the second one? We'll see. Second one is the amount of air present in the cylinder when a vacuum pump removes each time 1/4 of the air remaining in the cylinder. So solution here, amount of air present in the cylinder is equal to x units, which is equal to A1. Amount of air present in the cylinder after one time removal of air by the vacuum pump is equal to x plus x by 4, which is equal to 3x by 4 units, which is equal to A2. Similarly, amount of air present in the cylinder after 2 times removal of air by the vacuum pump is equal to 3x by 4 minus 1/4 into 3x by 4, which is equal to 3x by 4 minus 3x by 16, which is equal to 9x by 16 units, or it is equal to 3/4 whole square x units. Similarly, this is equal to A2. Similarly, we can calculate A3, which is equal to 3/4 whole cubed into x units, and so on. A2 minus A1 is equal to 3x by 4 minus x, which is equal to x by 4 units. A3 minus A2 is equal to 3/4 whole square x minus 3/4 x, which is equal to 3x by 4 units, as A3 minus A1 is not equal to A3 minus A2. This list of numbers does not form an AP. Now the third one, the cost of digging a well for the first meter is 150 rupees and rises by rupees 50 for each succeeding meter. So solution is cost of digging the well after 1 meter of digging is rupees 150, which is equal to A1. Equal to A1. Then cost of digging the well after 2 meters of digging is rupees 150 plus 50, which is equal to rupees 200. This is equal to A2. Then cost of digging the well after 3 meters of digging is equal to (200 plus 50), which is equal to 250, which is equal to A3. So and so on. Therefore A2 minus A1 is equal to 200 minus 150, which is equal to 50. A3 minus A2, which is equal to 250 minus 200, which is equal to 50. Therefore AN minus 1 minus AN is equal to AN plus 1. AN plus, that is A4 minus A3, A3 minus A2. Even for the previous problem it is also the same. This is AN plus 1 minus AN is the same. So therefore here you are having AN plus 1 minus AN is equal to 50 every time. So this list of numbers form an AP with first term A equal to 150 and common difference D equal to this 50. So next, going into the fourth one, the amount of money in the account every year, the amount of money in the account every year when rupees 10,000 are deposited annually to accumulate at compound interest (8% per annum). So solution for this is amount of money after 1 year is equal to rupees 10,000 into 1 plus 3 by 100, which is equal to A1. Amount of money after 2 years is equal to rupees 10,000 into 1 plus, the interest is 8, isn't it? So it is 8, not 3, plus 8 by 100 whole square, which is equal to A2. So amount of money after 3 years is equal to rupees 10,000 into 1 plus 8 by 100. After 4 years, it is equal to rupees 10,000 to 1 plus 8 by 100 whole to the power of 4, which is equal to A4. Have A2 minus A1 is equal to 10,000 into 1 plus 8 by 100 whole square. A2 minus A1 is equal to 10,000 into 1 plus 8 by 100 whole square minus rupees 10,000 into 1 plus 8 by 100, which is equal to 10,000 into 1 plus, these are all rupees, 1 plus 8 by 100 into 1 plus 8 by 100 minus 1. I have taken 1 by 8 plus 100 into 2000 common, so I am getting this. So this 1 and this 1 gets cancelled. So this is equal to rupees 10,000 into 1 plus 8 by 100 into 8 by 100. Now what is A3 minus A2? We'll see. A3 minus A2 is equal to A3 minus A2 is equal to rupees 10,000 into 1 plus 8 by 100 whole cubed minus rupees 10,000 into 1 plus 8 by 100 whole square, which is equal to rupees 10,000 into 1 plus 8 by 100 whole square into 1 plus 8 by 100 minus 1, which is equal to rupees 10,000 into 1 plus 8 by 100 whole square into 8 by 100. As A2 minus A1 is not equal to A3 minus A2, this list of numbers does not form an AP. Next, second question. Write first 4 terms of the AP when the first term common difference D are given as follows. First one, A is equal to 10, D is equal to A is equal to 10, D is equal to 10. So we have to find out the first 4 terms of AP when the first term A and the common difference D are given as follows. So what's the solution? We'll see. Yeah, we are having A is equal to 10, D is equal to 10. That is the first term and the common difference. So first term is equal to A, that is 10. The second term is equal to a plus d, that is 10 plus 10, which is equal to 20. Next, the third term is equal to a plus 2d also you can write, or second term plus 10. So which is equal to 20 plus d. So which is equal to 20 plus 10, that is equal to 30. So next, fourth term is a plus 3d, which is equal to 30 plus 10, or 30 plus d first we'll write, then 30 plus 10, which is equal to 40. So here the first term is a is equal to 10, then common difference d is also 10. The first four terms of the AP are 10, 20, 30 and 40. Here we have to just write only the first four terms. So I have written as 10, 20, 30 and 40. So now the second bit, a is equal to minus 2, d is equal to 0. So here the first term is minus 2 and the common difference is 0. So here I am just naming what are all the four terms, a1, a2, a3, a4. So it will become easy for you to understand. So a1 is equal to first term, which is equal to a, which is equal to minus 2. Second term a2 is equal to a plus d, which is equal to minus 2 plus 0, which is equal to minus 2. Then a3 is equal to third term, which is equal to a plus 2d, which is equal to minus 2 plus 0, or 2 into 0 it becomes 0. So therefore you are going to get it as minus 2 again. Then a4 is equal to the fourth term, which is equal to a plus 3d, is equal to minus 2 plus d, or 0. So minus 2 is the answer. So the first four terms of the AP are first four terms of the given AP are minus 2, minus 2, minus 2, 4 times. This is a constant throughout because you are adding 0 is the common difference. So you will not get any number other than minus 2 here. Now going to the third one, a is equal to 4, d is equal to minus 3. Why we are checking out whether the common difference is the same? What are the values which we are getting? So according to this we are going to find out what are the first four terms. So a1 is equal to first term, which is equal to a, which is equal to 4. a2, which is equal to second term, is equal to a plus d, 4 minus 3. Actually 4 plus of minus 3 I have to write. So which is equal to 1. Then a3 is equal to third term, which is equal to a plus 2d, or it is written as 1 plus of minus 3 because the common difference is d. So it is equal to minus 2. Then a4 is equal to fourth term, which is equal to a plus 3d, which is equal to minus 2 plus of minus 3, which is equal to minus 5. So the first four terms of AP are and the first four terms of an APR of the given APR 4, 1, comma minus 2 and minus 5. Next, going into the fourth one, a is equal to minus 1, d is equal to half. First term is equal to a, which is equal to minus 1, that is a1 is equal to minus 1, a2 is equal to second term, which is equal to a plus d, which is equal to minus 1 plus d. So we are getting this is equal to minus half. Then a3 is equal to third term, which is equal to a plus 2d, which is equal to minus half plus d, is equal to minus half plus half, which is equal to 0. Then a4 is equal to fourth term, which is equal to a plus 3d, which is equal to 0 plus half, which is equal to half. So the first four terms of an APR, of the given APR, first four terms of the given APR minus 1, minus half, 0 and half. So the fifth one, a is equal to minus 1.25, d is equal to minus 0.25. So a1 is equal to first term, which is equal to a, which is equal to minus 1.25. a2 is equal to second term, which is equal to a plus d, which is equal to minus 1.25 plus of minus 0.25, which is equal to minus 1.50. Then a3 is equal to third term, which is equal to a plus 2d, so minus 1.50 plus of minus 0.25, which is equal to minus 1.50 minus 0.25, which is equal to minus 1.75. Then a4 is equal to fourth term, which is equal to a plus 3d, which is equal to minus 1.75 plus of minus 0.25, which is equal to minus 2.00. So hence the first four terms of the given APR (1.25 minus 1.50 minus 1.75 and minus 2.00). Then going into the third one, for the following APs, write the first term and the common difference (3, 1, minus 1, minus 3 and so on). So solution, what is the first term for this? A is equal to the first term and the common difference d is equal to 1 minus 3, which is equal to minus 2. So first term is 3 and common difference is minus 2. Next, second, minus 5, minus 1, 3, 7, so on. In this, the first term a is equal to minus 5. Common difference is equal to minus 1 minus of minus 5, that is minus 1 plus 5, which is equal to 4. Then the third one, 1 by 3, 5 by 3, 9 by 3 and 13 by 3 and so on. So here the first term a is equal to 1 by 3. Common difference is equal to 5 by 3 minus 1 by 3, which is equal to 4 by 3. So a is equal to 1 by 3, d is equal to 4 by 3. Next, fourth one, 0.6, 1.7, 2.8, 3.9 and so on. So first term a is equal to 0.6. Common difference d is equal to 1.7 minus 0.6, which is equal to 1.1. So a is equal to 0.6, d is equal to 1.1. So fourth one, which of the following are APs if they form an AP? Find the common difference D and write 3 more terms. So what's the first one we'll go into? The first one, 2, 4, 8, 16 and so on. So the first term solution, the first term is a1 is equal to 2, a2 is equal to 4, a3 is equal to 8, a4 is equal to 16. So we'll find out what is a2 minus a1, a3 minus a2, a4 minus a3 and see whether the common difference is the same throughout or not. Then we can say that it is an AP. The given list of numbers are in AP, and then we can find out what are the next 3 terms. So a2 minus a1 is equal to 4 minus 2, which is 2. Then a3 minus a2 is equal to 8 minus 4, which is equal to 4. But here we are not getting the same number. a4 minus a3 is equal to 16 minus 8, which is equal to 8. Hence a2 minus a1 is not equal to a3 minus a2. So the given list of numbers does not form an AP. Going into the next one, second one, 2, 5 by 2, 3 and 7 by 2 and so on. So what is A1? What is A2 will say? A1, A2, A3, A4. A2 minus A1 is equal to 5 by 2 minus 2, which is equal to 5 minus 4 by 2, which is half. Then next A3 minus A2 is equal to 3 minus 5 by 2, which is equal to 6 minus 5 by 2, which is half. Then A4 minus A3 is equal to 7 by 2 minus 3, which is 7 minus 6 by 2, which is equal to half. So therefore we having A2 minus A1 is equal to A3 minus A2, which is equal to A4 minus A3, which is equal to half, and so on. So therefore common difference is equal to half, and the next three terms are of the AP are 7 by 2 plus 1 by 2, which is equal to 8 by 2, which is equal to 4. Then 4 plus 1 by 2, which is equal to 8 plus 1 by 2, which is 9 by 2. Then 9 by 2 plus 1 by 2, which is equal to 10 by 2, which is equal to 5. Then D is equal to half, and the next three terms are 4, 9 by 2 and 5. So going into the next problem, minus 1.2, minus 3.2, minus 5.2, minus 7.2. So A1, A2, A3, A4 is given to us. So we'll find out what is the common difference and see whether the common difference is same throughout. So A2 minus A1 is minus 3.2 minus of minus 1.2, which is equal to 3.2 plus 1.2, which is equal to minus 2. And A3 minus A2 is equal to minus 5.2 minus of minus 3.2, which is equal to minus 5.2 plus 3.2, which is equal to minus 2.0. The same way A4 minus A3 is equal to minus 7.2 minus of minus 5.2, which is equal to minus 2.0. Hence the common difference is minus 2, since A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A2. Are the same throughout. Are the same every time. So therefore the common difference or the list of given numbers form an AP with common difference equal to minus 2, and the next three numbers are the next three terms are minus 7.2 plus minus 2.0, which is equal to minus 9.2. Minus 9.2 plus minus 2.0 is minus 11.2. Minus 11.2 minus 2.0 is equal to minus 13.2. Then the fourth one, minus 10, minus 6, minus 2, and so on, 2, so on. So what's A1, A2, A3, A4 is given. What is A2 minus A1? We'll find out. Minus 6 minus of minus 10. Minus 6 plus 10, which is equal to 4. A3 minus A2 is equal to minus 2 minus of minus 6, which is equal to minus 2 plus 6, which is equal to 4. So A4 minus A3 is also the same. We are going to get it as 4. 2 minus of minus 2, which is 2 plus 2, which is equal to 4. Therefore the common difference is same throughout. Therefore A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. So therefore the given list of numbers form an AP with common difference D is equal to 4, and the next 3 terms are what we'll see. Next 3 terms are 6, 10 and 14. Okay, going into the next 5th one, 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, so on. So a2 minus a1, you are having a1, a2, a3, a4 given to us. What is a2 minus a1? We'll see. 3 plus root 2 minus 3, which is equal to root 2. Then a3 minus a2 is also equal to 3 plus 2 root 2 minus 3 minus root 2, which is equal to root 2. 2 root 2 minus root 2 is equal to root 2. a4 minus a3 also we are going to get it as root 2. So therefore a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, which is equal to root 2. Hence the given AP, given list of numbers form an AP with common difference root 2. So the next 3 terms are 3 plus 3 root 2 plus root 2, which is equal to 3 plus 4 root 2, 3 plus 4 root 2 plus root 2 is equal to 3 plus 5 root 2, and 3 plus 5 root 2 plus root 2 is equal to 3 plus 6 root 2. So now going to the next one, the 6th one, 0.2, 0.22, 0.222, 0.42, so on. So what is a1, a2, a3, a4 are given to us. So a2 minus a1 is equal to 0.22 minus 0.2, which is equal to 0.02. a3 minus a2 is equal to 0.222 minus 0.22, which is equal to 0.002. So a4 minus a3 is equal to 0.42 minus 0.32, which is equal to 0.0002. So therefore here you are getting the common difference not equal. So therefore the given list of numbers do not form an AP. Since we have a2 minus a1 is not equal to a3 minus a2, then do not form an AP. The given list of numbers do not form an AP. So going into the next one, seventh one, 0, minus 4, minus 8, minus 12 and so on. a2 minus a1 is equal to minus 4 minus 0, which is equal to minus 4. a3 minus a2 is equal to minus 8 minus of minus 4, which is equal to minus 8 plus 4, which is equal to minus 4. Then a4 minus a3, which is equal to minus 12 minus of minus 8, which is equal to minus 12 plus 8, which is equal to minus 4. Since the common difference is the same throughout, therefore it forms an AP. The given list of numbers form an AP, that is a2 minus a1 is equal to a3 minus a2, which is equal to a4 minus a3. So the common difference is minus 4. The next 3 numbers or the next 3 terms of an AP are minus 12 minus 4, which is equal to minus 16, Then minus 16 minus 4 is minus 20. Minus 20 minus 4 is minus 24. So the next three terms are minus 16, minus 20 and minus 24. So next, going into the next problem, 8th one. Minus 1 by 2, minus 1 by 2, minus 1 by 2, minus 1 by 2. So here you are having a1, a2, a3, a4 all are equal. And the common difference you are getting a2 minus a1 is equal to minus half plus half, which is equal to 0. a3 minus a2 is equal to minus half plus half, which is also equal to 0. So the common difference which you are getting is 0 throughout. So therefore a2 minus a1 is equal to a3 minus a2, which is equal to a4 minus a3, which is equal to 0. So common difference is 0. The next three terms of AP are minus half plus 0, which is minus half, again minus half plus 0, which is minus half plus 0, which is equal to minus half. So therefore these are the next three terms of an AP. Next, ninth one, 1, 3, 9, 27 and so on. So a1, a2, a3, a4 are given here. a2 minus a1 is 3 minus 1, which is equal to 2. a3 minus a2, which is 9 minus 3, is equal to 6. a4 minus a3, which is equal to 27 minus 9, which is equal to 18. So therefore this does not form an AP. The given list of numbers do not form an AP because the common difference is not the same throughout. That is a2 minus a1 is not equal to a3 minus a2. The given list of numbers does not form an AP. So going into the 10th one, A, 2A, 3A, 4A and so on. So A2 minus A1 is equal to 2A minus A, which is equal to A, and A3 minus A2, which is equal to 3A minus 2A, which is equal to A. A4 minus A3, which is equal to 4A minus 3A, which is equal to A. So here A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. Therefore the common difference is the same throughout. A4 minus A3, which is equal to A. So therefore the common difference is the same throughout. So the given list of numbers form an AP with D is equal to A, the common difference equal to A. And the next three terms of the AP are 4A plus A, which is equal to 5A, 5A plus A, which is equal to 6A, 6A plus A, which is equal to 7A. So 6A, 5A, 6A and 7A. Then the next problem, A square, A cubed, A to the power of 4, so on. A2 minus A1 is equal to A square minus A, which is equal to A into A minus 1. A3 minus A2 is equal to A cube minus A square, which is equal to A square into A minus 1. Then A4 minus A3 is equal to it's also not going to be equal to the same common difference. Therefore, a2 minus a1 is not equal to a3 minus a2. So the given list of numbers do not form an AP. If we check only two numbers, it's enough, because two of them the same common difference. If they don't have, we can tell that the list of numbers are not in AP. So going into the next problem, root 2, root 8, root 18, root 32, root and so on. So a1 is root 2, a2 is root 8, a3 is root 18, a4 is root 32. a2 minus a1 is equal to root 8 minus root 2, which is equal to root 2 minus root 2, which is equal to root 2. a3 minus a2 is equal to root 18 minus root 8, which is 3 root 2 minus 2 root 2, which is equal to root 2. Then a4 minus a3, which is equal to root of 32 minus root 18, which is equal to 4 root 2 minus 3 root 2, which is equal to root 2. So therefore a2 minus a1 is equal to a3 minus a2, which is equal to a4 minus a3, which is equal to root 2. So common difference is equal to root 2. So the given list of numbers form an AP. The next three terms of AP are root 32 plus root 2, which is equal to 4 root 2 plus root 2, which is equal to 5 root 2, that is equal to root 50. Then root 50 or 5 root 2 plus root 2, which is equal to 6 root 2, which is equal to root 72. Then we have 6 root 2 plus root 2, which is 7 root 2, which is equal to root of 98. So the next three terms are root 50, root 72, root 98. Then going into the next problem, root 3, root 6, root 9, root 12 and so on. So a2 minus a1 is equal to root 6 minus root 3, which is equal to root 3 into root 2 minus 1. Then a3 minus a2 is equal to root 9 minus root 6, which is equal to 3 minus a3 minus a2 is equal to root 9 minus root 6, which is, if you take out root 3 common, you are getting root 3 minus root 2. Therefore here a2 minus a1 is not equal to a3 minus a2. Therefore it doesn't form an AP. The given list of numbers does not form an AP. Then going into the next one, 1 square, 3 square, 5 square, 7 square and so on. Here a2 minus a1 is equal to 3 square minus 1 square, which is 9 minus 1, which is equal to 8. Then a3 minus a2 is equal to 5 square minus 3 square, which is equal to 25 minus 9, which is 16. So here therefore a2 minus a1 is not equal to a3 minus a2. Therefore it does not form the given list of numbers does not form an AP. Does not form an AP. Let's going to the next 15th one. 1 square, 5 square, 7 square and so on. 72. No, 73 and so on. So a1, a2, a3, a4 are given. a2 minus a1 is equal to 5 square minus 1 square, which is 25 minus 1, which is equal to 24. Then a3 minus a2, which is equal to 7 square minus 5 square, which is 49 minus 25, which is equal to 24. Then a4 minus a3 is equal to 73 minus 7 square, which is 73 minus 49, which is equal to 24. Therefore you are having here a2 minus a1 is equal to a3 minus a2 is equal to a4 minus a3, which is equal to 24. So the common difference is same. So therefore the given list of numbers form an AP. Then what are the given next three numbers we'll see here. So the given list of numbers form an AP. The next three terms of the AP are 73 plus 24, which is equal to 97. Then 97 plus 24, which is equal to 131. And 131 plus 24 is equal to 145.